Hello, and welcome to VeEX Broadband Basics. My name is Mike Collins. I'm a product manager here at VeEX. In this video, I would like to discuss amp balancing using active sweep, which is a preferred method in the industry for pre-qualifying a plant. This technique is particularly relevant for the ongoing DOCSIS network expansion, including the 204 MHz high-split return and the 1.2 GHz forward. One significant benefit of our method is that it only requires one technician, whereas traditional methods typically need two. This innovation effectively cuts operational costs in half. So let's get started. In this video, I want to discuss one of the latest developments regarding the CX380C and the SWP-BOX. By employing our field portable sweep system, we can efficiently balance the return plant using return sweep. When cable operators began to update their plant to support forward frequencies up to 1.2 GHz and return frequencies up to 204 MHz, one common approach is to only upgrade the active components, the amplifiers and line extenders, without updating the node itself. They have decided to update only the actives and not the node because the node replacements, the DAAs, are not ready to support the requirements for higher frequencies for both the forward side and the return side. But by updating all the actives, cable operators can prepare the plant to handle higher spectrum capabilities once they become available. Before activating the higher spectrum, they want to ensure that the network is balanced and ready for upcoming updates. So after the actives are updated, they'll send out a team of at least 2 technicians and 2 trucks to balance the return plant using just 8 continuous waves or CW tones. So in this picture, I show an amplifier on the left with a meter that sits there. A technician will sit there. One technician will stay at this amp or this first amplifier off the node and wait for the second technician, pictured on the right, to go to the next amplifier in line and shoot back the 8 CWs to the first tech at the first amp. They will then communicate back and forth to balance and set the correct levels for that return network. Then this process is repeated for the rest of the actives off of that first amplifier. However, with the CX380C and SWP-BOX kit, we can streamline this process to a one technician, one vehicle approach by replacing that first technician at the first amplifier with the SWP-BOX pictured on the left. And now our sweep solution only needs one technician to balance the return for all the amplifiers and active off of that active run. So pictured on the right, we got a technician that can just use the return sweep, talk back to the SWP-BOX, and balance the return. Here is a comparison when balancing the return using 8 CWs and VeEX return sweeps 401 sweep tones, which are CWs, between the frequencies of 5 MHz and 204 MHz. On the right, you see a screenshot where the spectrum recorded 8 CWs being shot back from the second amp to the first. This is what they would use to balance the return based on these 8 frequency locations. On the left is the same sweep trace, or is the same trace, but using sweep. And with this sweep trace, there are 401 sweep tones or sweep measurements between 5 and 204 MHz. A major difference in display between 8 and 401. You clearly get more resolution and a better detailed analysis of the return spectrum that is under test. Here's an example using standing waves when balancing the return using 8 CWs and active return sweep. Notice that both screenshots are set to 2 dB per division, which means each vertical line is 2 dB apart. The screenshot with the 8 CW shows all the CWs are around 11 dBmV. Nice flat signal going across. The screenshot with the return sweep trace shows a pretty substantial wave throughout the trace. when using 8 CWs to balance the return would clearly miss this impairment. Makes it a very good tool to use for not only balancing the return, but finding impairments. This approach provides added benefits to our customer. First off, the cost savings alone by turning a 2-tech job into a 1-tech job. That in itself is a game changer. But then using active sweep, we are utilizing 401 sweep tones, CWs, instead of just the 8 CWs that they're currently using. When measuring with 401 active sweep tones, this allows for a much deeper analysis of the return spectrum, a more accurate representation of the response of that return. Not only are you looking at all 401 sweep tones in that return, the other added benefit is you now can see impairments that could not be detected with only 8 points of data throughout that return, such as standing waves or peak to valleys and other impairments within that signal spectrum. So by using sweep, we can truly identify impairments in that plant or qualify it to be a good flat network ready to be used once they turn on their return spectrum to 204, once they turn on the UCDs and the return network to that capability. Then this setup has other uses beyond the 1-tech case. Once the customer has the sweep box in 380C, they can use it for many other cases, like forward sweep, just going with active sweep. Once they come in and update the DAAs to support 1.2 and the 204 megahertz network, you can then use the sweep box to insert at that DAA and continue sweeping and maintaining your plant network with the sweep box system. And then it's also used for extended spectrum sweep, so that they can use that portion of the sweep box application to just qualify forward sweep on the high end that has no plant. Many uses for the sweep box and the 380C with its high-tech spectrum analysis, OFDM analysis tool, cable modem, and all the other features contained within the CX380C. Once a technicians and the system has these in their hands, they're never going to want to give them back up. So get them out there, get them deployed, and let's reap the benefits. This concludes this video on the one technician, one vehicle using the CX380C and sweep box to balance and sweep the return path network. Thank you, and stay tuned for more VeEX broadband basic videos.